So, hello everybody. So today I'll be talking about my project. So let me just first put this on a slide start mode. Okay. Yeah. So my topic is the LinkedIn job recommendation system. As you know that we've already spoken about the data set in my previous presentation, where the data is scraped from LinkedIn, which consists of 1.3 million job listings. This data was scraped in 2024, and the size of the data set, helps in analyzing the market and identifying the jobs that are in most detail and the industries that are like hiring more right now in this market. And moreover than that, it helps like recruiters or like employers to understand the trends and the talent that is out there in the market. So for technology stack used within my data set, I've used Pandas, Matplotlib, and Seaborn to visualize my data. And scikit-learn, I've used k nearest neighbor since we're predicting the closest neighbor to a particular position. And I've used label encoder to encode a few columns within my data set. And I've used TF-IDF. TF-IDF is nothing but the term frequency, inverse document frequency. And in that, I've used the vectorizer model in order to like convert my text data into numerical data. I'll be discussing more about that in the further slides. And I've used Streamlit to demonstrate my model. Discussing in detail regarding my data set. So after manipulation of my data, I included indicators such as the last time processed in order to like ensure the data quality and keep track, so that if somebody tries to search for a particular job, they get to know when was the last time processed, so that they can apply to that particular job or understand by when they could apply or how late they are to apply to a particular job. And I've discussed in detail about the job attributes such as the company and where the company is located and so on. And yeah, as I mentioned, that is the detail regarding my data set after manipulation. And going deep into like my EDA process, I cleaned up the data as I mentioned in the last presentation, where I said the got summary, the got NER, and is being worked were like unnecessary columns. I've dropped them, and as well as dropping them, I've even dropped get location and a column which is called get location, and the other column is the first time processed. I will discuss more about that when I discuss about my code. So coming to the focused data analysis, yeah, as is in the upcoming slides, you'll be seeing this analysis is I've done based on the job market, on like the trends of which country has like more job openings, or which country. I mean, what are the type of work modes that are presently in the job market. So that is about my EDA. So as I mentioned, this I've created a visualization from my data set showing the count of jobs that are located in millions per country. So US has like around 1.18 million, I think, and United Kingdom has around somewhere between 0 to 2 million, and so on. And so the type of work is majority of the companies are looking for a person who can come on site and work, as you can see from the visualization of the data set. And yeah, so coming to the part where I've discussed about the pre-processing, now I'll be talking about the implementation. Like, after identifying the inconsistencies, I took steps to clean the data set, which included like encoding the search position. I mean, I had to encode the search position because I took a particular search position to like predict the closest job titles to it. So, which means that I had to like label and code the whole search position column first. And after that, before that, I've removed like the other columns which were unnecessary, like the got summary, the got NER, and is being worked, and the first scene, because yeah, I found them repeating in the other columns direct or indirectly. And to handle like the job title column had sentences where it specifically spoke about the job description. So since you cannot label and code such big text, I had to come up with a plan of using TF-IDF vectorization. As I mentioned, that it converts text data into numerical data, and by fitting this text data into the TF-IDF vectorizer, I transform the job titles into like numerical vectors, which enabled in like efficient prediction to the nearest job titles. And by label encoding the search portion column and transforming the job titles using TF-IDF, TF-IDF, I prepared the data set for the predictive modeling. And yeah, later on, I fitted the model after label encoding. I fitted the model with KNN, and after transforming my data set into TF-IDF vectorization, I got I got a data set. I mean, for a data set size of 13,048,454 rows, I got 8,424 unique words, which showed like the shape. When I saw this, I got to know this when I saw the shape of the matrix after the model was fitted. And yeah, I used k nearest neighbor to, as I mentioned, I used k nearest neighbor to fit the model. And coming to the model implementation, I would take you to the model so that you could understand better. So yeah, as I mentioned, in my project, I the first thing I've done is like loading the data set and importing the necessary libraries for it. As you can see, I've imported pandas and numpy, and with pandas, I've loaded my data set. I've seen the first 10 entries of my data set, and I've seen each columns. And then to understand the data better, I've seen like how many unique values are present in each column. So based on the search city, I've seen that Baytown has so and so number, and yeah, as you can see here, and the countries too. Like I've seen which country has more jobs and so on. And based on this, I saw my data and I tried to find out how many unique job links are there, or how many unique last time processed columns are there, and so on. From there, I can see that unique job titles had like 58,454 count, and companies had like 90,000 jobs, and companies had like the companies column had like 90,000 unique data. And from there, like I like took to understand the shape of the project, I mean of my data set, which was like, as I mentioned, 13,048,454, and it had like 14 columns. And here I visualized my data based on the country location, as I've seen in the presentation as well. And going down, I wanted to check the unique values which are present in each column, like before. And after that, I wanted to check the null values. I've just seen a very few null values, so I thought of not, touching them, since because they don't directly impact anything. And as I mentioned, in order to like go ahead with model implementation, I had to drop a few columns. Like, but suppose I had to drop the job location column, because yeah, I had to drop the job location column because, as you can see here, yeah, so the job location states the city and the state it is located in. But there's another column named search city, which has a city where the job is located and the country is already located in. So I felt like you can know which city is located in which country rather than going more in detail. So I felt that would be unnecessary. The location exactly would be unnecessary, and hence I dropped that column as well. And yeah, like you could, as I mentioned, the got summary and got NER and is being worked had data types of TNF, which I felt were unnecessary as well. So once I dropped them, I kept the job link, the last time process, the job title, the company that is hiring, the search city, the country, the positions which they're hiring for, the level of the job, and the job type were my columns which I wanted to fit my data into. I mean, fit my model with. So then I imported I imported a TF-IDF vectorizer from sklearn feature extraction text, which is like an NLP model. So basically, if I like stressing more about what TF-IDF is, like as I mentioned, it's term frequency inverse document frequency, or the full form of TF-IDF, and this helps in like converting textual data into numerical data. And so the reason why I've used this is because, as you see here, the job titles have like a description which is difficult to encode as one or two or particular things, like into a particular order. And hence I had to like use TF-IDF. And how I came up with that idea was I went through a few research papers where, in majority of the recommendation systems, TF-IDF vectorizer was one of the main, models that they use into like convert large data sets into large columns which had text into numerical values. So how this works is, it considers the frequency of words in each job title, and it inversely weighs them based on their frequency across the data set. And then this process ensures that the common words across all the job titles, but suppose if there's off, an, or in, or like these repetitive words have like lower weights, while the ones which have like, but suppose if I'm searching, if a particular job title has like an account executive or something, and which are like unique, they have like more weights. And this is how like TF-IDF categorizes them. And once the TF-IDF vector represents the semantic meaning of the importance of the words, I used cosine similarity. As you can see here, I've imported cosine similarity from k nearest neighbors. So like once the job titles were like transformed into TF-IDF vectors, yeah, the job title column was like transformed into TF-IDF columns. Sorry, once the job title column was transformed into TF-IDF, uh, I used cosine similarity to like measure the angle between the two vectors, indicating how similar they are. And like in the context of my as you know the working in my model, it like compared, it calculated the difference. I mean, the distance between, or the angle between my vectors, such as like for a particular search position vector, it calculated the distance with the job title vector, and it gave me the closest value to it. As you can see here in my model, like I've fitted the model with, I've transformed my job title column with with the vectorizer, and then I fitted with the KN models. Like I asked it to like give me the top six nearest neighbors to it, and the metric I've used here is cosine. And once I fitted that model, it showed the model, like the after the vectorizer had fitted the model, like after vectorizing and fitting the model, it showed that it had like 84,424 unique values. And then I wrote a specific function to like predict predict a job title for a particular search position. As you can see, again, I've like transformed like the search position as well to a vector, since my model was already fitted with the job titles vectors. And then I gave it a function to calculate the job details and the similarity scores for each and every one of them. And hence here, like when you put in like a particular position, like put data analyst here, this is an example, and it gave the top six searches for like data analyst based on the similarity score as well. And it gave the link, the city where it is located in, and which country it is located in, and the last time it was processed, and so on. And in the same way, like I visualized the um, results as well. Like for suppose here you see the data analyst, there is two job titles, which is data analyst one and data analyst. So it shows that data analyst and data analyst one are both like closer to what you've asked for, and based on the job title, it has like matched it. And so yeah, so and again now, uh, I would like to like show you how I've implemented the model on Streamlit as well. So for this, just give me 1 minute. So yeah, so once like I open the file after putting it on Visual Code Studio, I given my command, and then once I press enter, it opens my default browser. And then yeah, so So hi, it says hi, and then there I go and put in, for suppose, let's say machine learning engineer, and then I press enter, and then it runs, and then it gives me like the nearest job recommendations for that, the company, the job link, the city it is in, and the similarity score of how similar of a title, I mean position you looked for based on the job title. So yeah, this is how my application works. And it's not only machine learning engineer, you can even give it a data analyst, as you've seen, or you can just give it something randomly as a AWS developer. Sorry, my bad. AWS. And yeah, based on the word AWS, I think, yeah, it is going to show me the closest job titles with an AWS developer as well. So yeah, see, as you see, like if it feels like the words do not match or the distance between them differs quite a bit, at least it'll show you a difference in the similarity score here. See, for suppose here it has AWS developer, and since it's like matches word to word, it gives me one as a similarity. And for AWS cloud developer, it has a word called cloud in between, and hence it gives me a similarity score of 0.80. And this is how, like, so as we've seen the working of my model again, now let's get back to the presentation. So yeah, I've spoken about how my TF-IDF model works. So let's talk about how did I come up with the plan and why did I use it. So I use TF-IDF vector to like reduce my like increase my scalability, and since the text since I need to like represent it in the form of text, and since TF-IDF can handle like large data sets efficiently, and it can convert them and it can convert the textual information into numerical vectors, I used TF-IDF. And yeah, it can like handle different variability in the words as well, which like are mentioned in the job title. Some job titles might have the symbol of dollars, or some other like symbols which might not be able to be encoded, and hence like that is where like TF-IDF take like comes into play. And yeah, as I mentioned in my explanation of the code, um, considering the size of the data set, TF-IDF was like the most robust solution which I could find after going through numerous research papers. And yeah, while it preserves the semantic meaning, it helps in like ensuring the numerical representations to like it helps in like ensuring that the resulting numerical representations capture the essence of the job titles, which like facilitates to accurate analysis and recommendation. So that is why I like used TF-IDF. So coming to the summary of my project, yeah, as you've seen, I've cleansed my data. I've prepared it for like transformerization with TF-IDF vectorizers, and then I've fitted them into the KNN model. And after fitting them into the KNN model, I selected a matrix for of cosine, and I gave it a command to like give me the top six closest neighbors to a particular search position. So like when I enter in the search, like as you've seen, when I enter in a position name, like search position is nothing but a position's name. When I put in a position's name, it gives me the closest job title to it. And within the job title as well, like as you've seen that in the job titles, though there were many words, the main words that caught the attention were like account manager or data analyst or so on, and that matched with the and like when I transformed that into a vector and when I applied cosine to it, it matched the closest angle between the both of them, and it gave me a similarity index of 1 or 0.8 or 90%, 80%, like the accuracy of the similarity. And yeah, based on that, I've even drawn impacts of my results as well. So that is a summary of my project. And coming to the conclusion of my project, yeah, so taking inspiration from like established practices such as like like the recommendation systems in Google or like LinkedIn or Meta or whatsoever, the project was like successfully developed for recommending, or predicting jobs or predicting job titles that have like based on the search position. The quality of the data set like enhanced by like rigorous data pre-treatment, which included like data cleaning and like label encoding, and then and, like, fitting it with transforming it with TF-IDF vectorizers, and it guaranteed like an accurate and trustworthy analysis. The system like effectively finds the closest nearest neighbors after like training it with KNN cosine, a KNN model with the cosine metrics. And yeah, this allows users to like find an appropriate job title based on a particular search position, and this helps like this model like not this model but exactly, but yeah, these kind of studies or like these kind of machine learning techniques help to like improve recommendation systems more efficiently. It's not only about LinkedIn or any other recommendation system. Like, for instance, recommendation systems can be of any types. But suppose you can take Netflix, or you can take any particular applications nowadays, like even a food application where you order something related to a burger or some burger, and then gives you suggestions based on other companies or other providers which even sell you burgers, or you can like it shows you that you can even order these as well. So I feel like in terms of recommendation systems, NLP plays an important part, and one of the most important machine learning model within that is like the k-nearest neighbors, and hints have like demonstrated that taking a data set that has like the LinkedIn recommendation, like it had like I've taken a data set that had like the LinkedIn job listings, and with that I've effectively shown how the model can be made and how it is done. And that is it with my conclusion. So thank you very much everybody for attending. See you guys